A few words about myself, just quickly. I'm writing software for 25 years, started in school. And for about 15 years, I was managing a team, different teams, up to 120 people sometimes of developers in Ukraine mostly. And I'm also a Java developer myself, a project manager, and an owner of a company who was managing all these people. You can see my Twitter account, you can see my blog, please subscribe. That will be interesting because everything I'm going to say today is explained in my blog and many different articles. So I'm going to present you the way we manage programmers, the way we manage projects, and it's quite different from everything you've seen in all other places. So that's why you definitely will be interested to see more content from me. Here's the subject. Here's the problem. So in all my projects, for many, many years, I had the same as these people are saying about the industry in general. So all our projects, all the software development we have is basically a chaos. So we fail, we slip the schedule, we miss time, we don't complete the requirements, we don't deliver, we spend money, and customers are not happy. I've had that for 15 years in most of our projects. And I found that statistics in the report which says we're in chaos, and they say that about like 94, which is almost 100% of projects actually fail and have to restart. That's what the report says about the entire industry. And they say that only 7% of that projects fail because of technical incompetence. So the problem is not with programmers, the problem is with the management. They fail because we miss requirements, because we don't understand what to do, because we cannot control what we do, because we cannot manage ourselves. It's not because we're bad programmers, not because we don't know Java or Ruby or whatever. It's because we don't manage ourselves the right way. And I had the same. So that's why I tried to solve the problem and invented the methodology, which actually, in my case, in my experience, in our projects, actually helped us a lot to resolve that and be successful. There are 5 things. The methodology is quite big, but there are 5 things I want to highlight today, and they're quite controversial. That's why it's interesting. So 5 things, how we are different from everything you've seen before. Thing number 1. Traditionally, you believe, or they believe, that the teamwork is so important for the success of the project. We think that it's so important to keep the team together, to make sure that people stay together, that they are motivated to work together. And the job of the manager is to make sure there's a team there, make sure that people match to each other, and this is the key factor for the success of this team, for the success of the project. So we just spend a lot of time on the team building, on team spirit, on making sure that people love each other, and that's how we guarantee the success. I think that this approach is for lazy managers. This is for people who cannot understand how to manage programmers. This is for people who are not really managers. This is what causes troubles in projects. This is what leads to loss of the A players. Do you know what A players, B player, and C player is? This is the terminology from the sales, actually, but I think it can be applied to programming as well. So in any team, we have A players, B players, and C players, like senior programmers, medium programmers, and junior programmers. So A players, they're always aiming for excellence, so they're always trying to do better. And C players are the people who we kind of have to remove from the team. So this approach with the teamwork, in our experience, is really good for C players, and it's really good for lazy managers. In our case, we do the opposite. We aim for individual responsibility, not team responsibility, but individual responsibility always. So we don't like the idea of the team in general. We always pay attention to who is doing what, what's the personal scope of the task, and we scope that task individually. So we always assign tasks individually to programmers. We always give tasks to, we always control the results of each programmer individually. So we don't do the teamwork at all. So we clearly define the rules of the work. And this is a lot of job we do on the management side. We always have an architect in our team, who is the person who is personally responsible for the success of the project, and who is making all technical decisions. So we don't have any democracy in our teams. We don't vote for technical decisions. It's always the architects who makes the decisions, and always the players or developers who are responsible for their own scope of work, for their own tasks. And we always work remotely. So that's probably what is different from other teams, but we work remotely. So all our programmers, they stay in their own places, in their own countries, and we don't have a central office at all. So all our teams, they work remotely, and they communicate only electronically. So that also helps us to stay away from this team idea and focus on individual results idea. That's first thing. The second one is overtime. Traditionally, what's on the left, it's traditionally, what's on the right, it's our approach. So traditionally, programmers are managed by stress in most cases. So we just know that programmers in general, I mean, managers assume that programmers in general are kind of lazy, so the best way to manage them is to put the deadline as close as possible and then stress them so they work overtime, they work on the weekend, and that's how they will achieve better results. That's how they will be more or less under control. That's the only way bad managers can control people, is just to keep them under stress. And that's how programmers will do something. So we give them deadlines, we give them stress, and we get overtime. So they work more, they spend more, and we believe, and managers in general assume that if people stay overtime, if they stay in the office after the office is closed, these are the good programmers. These are the good developers who stay overtime, who spend more time in the office. In our case, it's quite the opposite. So we don't want programmers to work more, we want to work them less. We expect them to develop and to commit their code and to close their tasks and to close their tickets and to do anything voluntarily, only when they want to do that. So we allow our programmers to reject tasks if they don't want to do them, if they don't feel like it. So we just give them tasks and allow them to choose whether it's a good time for them to work on them or not, whether it's the good task for them or not, and whether it's a good time for them to do it now. And in most cases, in most projects, our programmers, when the project is full of work and we have a lot of tasks, they spend 3-4 hours a day for the development, not more. So we never work 8 hours a day and forget the overtime. We don't have overtimes at all. So 3-4 hours a day, in my experience, it's the maximum time a good programmer can spend a day for actually productive work. And they do it voluntarily, because I'll say about it later, but because we pay for results, that's why they're really interested to do the work, because they get, they get money for that. So they do it when they feel like it. Sometimes they commit a lot of time one week, and the next week they commit less time, so the graph jumps ups and down. And it's not under control of the manager. The manager doesn't push the person, any developer, to any amount of work. If we don't have enough resources, if we don't have enough people to close all our tasks, then our managers have to find more people. Then we have to find more resources. I mean, developers, programmers, resources, whatever. So we find more of these resources, and it's a job of a manager how to find more resources and give that tasks to that people. But we never stress programmers. We never expect them to work more than they want to. So it's a job of a manager. That's what I'm saying. So our managers are way more busy than traditional managers, because they really have to do the management work. They don't need to stress anybody. They need to schedule tasks on a timeline. So we don't have overtimes at all. Number 3 is learnings. I'm going from the last critical to the more and more critical. So learnings. Traditionally, in any project which I've seen before, people, programmers, are the core, are the main holder of information and knowledge. So this is the most knowledgeable part of any project. This is the most important part of any project. If programmers know enough about the stuff they develop, then the project is more or less successful. The more they know, the more knowledgeable they are, the higher the chances of success. And if some new programmer joins the project, then it takes some time to ramp up that person, to teach that person all the new technologies and everything which is in the project. And it takes some months, it takes 2 months, and it takes sometimes 3 months. So it takes long enough to bring somebody new to the project. This is a traditional way. That's what we have in most projects. And in most cases, we have so-called experts, subject matter experts. So people who know most they possess the majority of the knowledge in the project. So they know a lot, and these people are the key decision makers in the project. If we lose that person in a traditional environment, if we lose that expert, we lose a lot. And that's why that people kind of start to control the owners of the project. It's not the manager who controls the development environment. It's the people, the experts, who control people with the money. So they tell the customers what's going to happen. Not the customer says what's going to happen, but the people who are experts, they start to manipulate people with money. This is what I've seen in a lot of places. We changed that completely. In our case, we don't really like the idea of having people who know too much in the project. We want our artifacts, our documents, to know too much. We want our product to be self-explainable, so that anybody tomorrow joins the project and can understand everything in just a few hours. It may sound crazy, but it really happens in our projects. We bring sometimes new programmers to the project which is 1 year old, and that new developer starts writing code and making new classes, writing new unit tests, committing code in just 1 hour. So it doesn't take a month or 2 months to learn, because we don't have experts. We don't have people who know too much. We only have documents and source code and diagrams which explain everything. How we achieve that? First of all, we rotate people. We change people from project to project. We move them, because we understand that the more experts we have, the bigger is the trouble for us. We don't want experts. We want people be, how to say it, like commodity programmers. So they can work here, and then tomorrow they can work there. So they can go from project to project and can contribute there as effectively as they were contributing yesterday in a different project. So first of all, I'll say a few words about it later, but here we rotate them, we change them, and second, we promote the idea of always blame the project, don't blame yourself. So if you start working in a project, you don't understand anything, you don't need to learn, you need to say that the project is not sufficient enough for me to understand how it works. If you open the piece of code, if you look at it, you don't understand how it works, you don't learn it, you don't ask anybody, you don't find an expert. You just say, hey, your class or your piece of code is not clear enough, so fix it. And then we fix it for you, and then it will be easier for you to understand it later. So we always ask programmers to blame us, the project, for not being clear enough. And we fix that, we improve the quality of the documentation, and we bring it back to you and ask, can you fix it now? If you can fix it now, then again you blame us. And then in a number of that cycles, eventually the project becomes as clear for you so you can understand it in half an hour. You'll probably have questions, we'll get back to it. Number 4, we have 5 in total. Number 4, meetings. Traditionally, people believe that the more programmers communicate, the more meetings they have, the higher the chances of success in the project. The closer they stay together, the more these face-to-face communications they have, the higher the chances that they will actually understand what's going on and they will produce something. So that's why we have these Slack chats, we have these Skype calls, we have conference calls. Sometimes the senior developers, they spend half of their day, or maybe sometimes the full day, in just meetings and just talkings and exchanging information. And this is what managers believe is a good way to do. They think that senior developers have to be in that meetings. They have to spend time on talking instead of writing code. And even Agile Manifesto says so, like face-to-face communications is always better than documentation. We completely disagree with that. We believe that the more meetings you have, the more informal communications, the more of these chats you have, and the more face-to-face calls or whatever you call it, like remote calls, doesn't matter. The more you have of that, the bigger the trouble you cause to the project. Because you exchange the information which stays nowhere. We talk to each other, I explain you how it works, you understand how it works, but tomorrow somebody else will join the project and that person will not know how it works. So we will have to explain again, we'll have to explain again. So every minute spent in a meeting is the wasted money of the customer. So the more we talk, the more we exchange information informally, the more money we waste, which is customer is paying us. So good developers, I believe, and we seriously preach this idea, the good developers, good engineers, they exchange information through documents, through diagrams, through the source code, through formal written communication, which is maintainable, which we can get back to in a year, in a month, in a week, in an hour, and understand why that decision was made, who made that decision, what was the reason behind that decision. To achieve that, not to enforce, but encourage people to actually use documents instead of calls, we don't allow them to call. We just, that's so easy. We just don't, they just don't have phone numbers of each other. So we don't have that Slack chats. We don't have that Skype calls. They don't know, I mean, they know each other, but only through, we work on GitHub. So they only know their GitHub accounts. All they can do in a project, if I don't know anything, for example, I joined the project and there are like 20 developers in there, and I don't have some information, I can't call anybody, I can't ask anybody. All I can do is I can submit a ticket and say, hey, this piece of information is missing from that document. Can you please, fix that and put that piece of information into that document? And somebody will fix that for me. I don't care who it's going to be. I don't care who's going to fix that. All I care about is that I look at the document and I find that missing piece of information. That's the idea. So if you allow programmers, to talk to each other, they will. If you allow them to call, they will, because it's naturally better for us, to communicate, face to face. Just here's my friend sitting next to me. I'm going to ask him. I'm not going to, get the document. I'm going to just ask and get the information. We completely disallow that. For us, it's easy because we work remotely. So all our developers are somewhere. They're like, in different countries and different time zones. So we don't have a central place. So we just keep them like that, and we don't allow them to, to get into some Slack chat and talk. All they can do is communicate through ticketing system, through the source code. And that's how we achieve that result. So we have only documents and only diagrams. And I'm saying it again, sometimes, and it's very often, we have projects which are 1 year old, and the new developer jumps in, and there's like 50,000 lines of code, of Java code, like serious Java code. And the new developer jumps in and starts writing code in just 1 hour. It's unachievable in a traditional project configuration. The last one, and we have questions. Salaries, the biggest problem. So traditionally, we believe that, everybody believes that it's so important to keep the developer happy and to keep the developer safe, and it's, to get the loyalty from the person. So we need long-term contracts, good salary, paid every month, and that's how we're going to achieve, good results from that particular person. So we usually pay for, well, not we, but you usually get paid per month, per time, sometimes per hour, sometimes per month, but it's always for time. You just sit in front of the computer and you do something and they pay you for this time. You achieve the result, they pay you. You don't achieve the result, they still pay you. You work, they pay you. You don't work, they still pay you. That's a huge problem, I believe, especially for A players. Remember that A, B, C players? We have A players, people who really want to achieve something, and we have C players who just enjoy being in front of the computer. So the A players, they don't like that. They will leave your project, and they will not be productive at all, because this format, puts everybody on the same level. Because if I'm the A player and I produce result, I'm still, paid more or less at the same level as the C player who produces 0 results. And then there's soft skills. So then in the end, to make a decision who's going to get more salary, who's going to get a raise, who's going to get who's going to get fired, we use soft skills. Who is the nicer guy in the team? Who talks more? Who is more communicative? Who is the good match for the team? That's how we decide who gets the raise. Instead of looking at the real results, instead of looking at the numbers, not numbers, but the actual results that people provide. So we use the soft skills. It completely demotivates A players, in my experience. So we remove that. We don't have salaries at all. Well, we pay money, but we don't pay salaries. We pay for results. Every time developers complete something, close the ticket, file a bug, basically 2 things: close the ticket and file the bug. So fix the bug or file the bug. We pay for that. And we do micropayments. So we pay our developers in like really small micropayments. We can do that because we work with remote programmers and freelancers mostly. And we pay them through like PayPal, Bitcoin, whatever. So we just, we have these transactions, many transactions every day. And the more they commit, not commit, but the more results they produce. It's not about the number of lines of code. It's not about some productivity metrics. It's about close the task or not close the task. Here's the problem: you either solve the problem or you don't solve the problem. When the problem is solved, and we have small problems, we always have small tasks, half an hour, 1 hour, really micro tasks. The task is closed, we pay. The task is not closed, we don't pay. So there's no salaries. This is how we make it so easy to measure the performance and productivity and motivation of everybody in the project. Because we don't pay in the end of the month, we pay when the task is closed. So I'm basically done. I think you will have questions, but let me summarize. So in this model of work, which I just explained, we've been working for about 3 years already. 250 developers went through this model. So 250 people actually tried that and get some money from us in different tasks and different projects. Mostly Java, 90% is Java. 25 projects completed. Commercial and open source. We have open source projects at all, so you can look at them, come to me later, I'll give you my coordinates, you can look at the GitHub account and you will see a number of projects which were completed using this technology, this approach. And you will see how we communicate to each other in GitHub tickets. So you will see how we get rid of these meetings at all, and all our communications are there. So you will see even how we pay programmers, because all these like payment, successful payment notifications are there in GitHub. It will be quite interesting. And we produced about 300,000 lines of Java code. It's a pretty big amount of code. And all of these projects were really successful comparing to what I had before for many years. So I'm asking you to follow me, subscribe to the blog, and you will learn more. So now questions from you guys.
So we have plenty of questions in Slido. And I will start with the most voted ones, okay? And so you talk about information, but what about designing together? Because the design is a product of a conversation.
Well, yeah, yeah, I've heard that question many times. So people, again believe that the design is the result of the conversation, of the work of the group. But in my experience, it's not that true. In my experience, the design is always the result of one person thinking and asking people around. So when we start a project, we always have some person as an architect, in the role of the architect, and that person is responsible for creating the skeleton, the prototype of the product. That person may collect information from other people, asking, what do you think about this? I'm not sure about choosing the database, so tell me which database would you think I should use? Tell me about the technology I should use. So questions are welcome. The architect has to ask questions. This is perfect. But the final decision, the final design, has to be made by one person. That's what I believe in. We pay for answering questions, of course. But all questions are like tickets. So let's say, for example, you're a good database engineer, yeah? And I am like an architect, and I don't really know what kind of database to choose, MySQL or Postgres. So I'm submitting a ticket and saying, hey, I miss a comparison of MySQL and Postgres. I need a comparison, provide it for me. This is a task for you, for an hour. So you work for an hour, give me a table, a spreadsheet, comparing why MySQL is better for us and why Postgres is better for us. And I say, thank you very much. I know that. Now let me make a decision. So that's how it should be. Iteratively go through questions and answers, and then finally I will be able to make my decision. Again, it's not easy. It's way easier to sit together in the same room and say, hey, what do you think about Postgres? And you say, well, MySQL is better. Oh, that's right. Thank you very much. And then I make a decision. But then in 2 months, somebody will come and say, hey, why the decision for MySQL was made? And I'm gone from the project because, they fired me already. You're gone as well. They fired you too. And then the question is, who made the decision? Well, there were 2 guys, yeah, I still have the phone number of the one guy. Let me call him. But instead, we're going to have the detailed conversation and the ticket for that. And everybody will be able to jump in and see, yeah, that guy who is fired asked the question, why MySQL? And then another guy submitted a detailed explanation of that. That's a perfect traceability for that.
My friends, there are so many questions in Slido. Go ahead and vote for questions, because let's make it moderated, okay? And I'll ask the topmost questions, and there are many. So it's not a question, it's like a complaint. 3 hours of work? Are you kidding? My manager will kill me, the stock will decrease, and the company will close.
For 3 hours of work?
3 hours of work, are you kidding me?
Yeah, per day, yeah. I believe, honestly, that a productive, like a good engineer, well, I'm talking about myself, first of all. So I can imagine working for 8 hours a day on something which is not my personal project, which I really love. So working for somebody, for some project, for money, 3-4 hours a day is the total maximum a normal, good engineer can really handle. I think so. Otherwise, it's 8 hours and 5 hours of Facebook watching, out of this 8 hours. So it's going to be 3 hours in any case. So you're not going to be productive for 8 hours. It's not possible. You can really write code for 3, sometimes even 2 hours is enough. But I think that in general, programmers have to be paid way better. So we need to earn way more. We need to make more money per hour and spend less time in front of the computer. So I don't know how much you're making, but an average, like say, for example, now programmers are making like I don't know, 25 euros an hour, 30 euros an hour. They have to make 100, but work 3 times less. In this case, the work 3 times less, but they have to be paid for result, not for the time. So now we're all paid for 8 hours, from the morning till the evening. Whatever I do, you pay me. But it should be the other way. It should be the opposite. You pay me way more, but only for the results I produce. In the end, it will be the same amount of money in cash, maybe a little bit more, but I will be focused on results. I'll be really motivated and interested to actually work instead of just pretend that I'm working, just sitting there and just going to the office. So 3 hours is the maximum. Well, 4.
The next question. Who decides how much time the problem takes to solve? If it's the business, how can he estimate? They always think the task is easy.
Well, yeah, we just in our approach we always give the same budget for all tasks. So we always give it a really small budget, and then we use this technology where we allow developers to return back the code in incomplete state. So I guess you're developers, right? Who are the developers? Who actually write code here? Like 75%, maybe more. So you should understand that. Let's say you get a task for, you have to implement that feature, and the feature is way bigger than 1 hour. So we don't ask you to, we ask you to cheat, basically. We ask you to implement provide the high-level implementation with certain parts not implemented yet. So we say this feature, for example, I have to be able to click the button and log in. And this is 1 hour for you. And you understand that's 1 hour, it's not enough. It should be like 5 hours. So you just create a button. It says login. It's clickable, but it doesn't log in. So you just return back the code to me, to the master branch, and say the button is there, but there's a marker says to do later, implement the login this and that way. So you kind of help us to improve, to design that, and then by introducing the high-level solution and then keeping the markers of where other programmers have to contribute more. So you return back the code with the markers, and then these markers we convert back to new tasks. So we ask developers to help us break down the problem into smaller pieces. That's how we do it.
Next question.
We call it puzzle-driven development. So we call these pieces puzzles.
Puzzles.
So we give you the task, you return it back with puzzles inside. And then somebody else will solve that puzzles. And while that people will solve the puzzles, they will introduce new puzzles. So when we start developing, it's just a few puzzles, and then it goes like that. So there are like 100 of puzzles. And then when all of them gets fixed, the software gets back and it starts to work. Well, it becomes completely functional. If you're interested, come back to me later, I'll explain.
Next question. Isn't there a lack of quality? Developers deliver the code and go. There is no motivation in delivering good code. Who decides whether to pay or not?
Yeah, it's a good question. So definitely, and we really ask our developers to be lazy. So be lazy, don't try to do more than you can do, but be prepared that the quality control is really strict in front of you. So when you get the task and you have to implement something, do as little as you can. You don't need to, to make it high. Don't make the quality higher than the quality bar we have in front of you. And the quality bar is quite high. So for you to return back the code to us, to the master branch, it has to pass 2 code reviews plus the automated merge instrument. So we're going to merge your branch back to master branch only if all the tests and all the static analysis and all the coverage control, everything passes. So for example, I'll give you an example of how high is the quality bar for us. Static analysis is the step in the build for us. So the build is not going to pass if the static analyzer says there are any bugs, any warnings, any complaints. You know what static analysis is, right? Who doesn't know what static analysis is? Okay, good. So you understand that static analysis is usually used as a tool which we run on the code which generates some, spreadsheets, some interesting web pages, which we'll look at and say, hey, the rate of our static analysis warnings is a bit lower than yesterday. That's great. But there's still a lot of them, still a lot of complaints. Look at your projects. Run the static analyzer for your project, no matter what language you're using. You will see there are many of them. In our case, there's 0. So we run the static analysis on the entire code base, and there should be 0 warnings, which is really difficult to achieve if your static analysis is configured properly. It's really difficult to achieve, especially if there are many people working there and the code base is quite big. In our case, no matter how big is the code base, no matter how many developers are there, we're not going to merge your stuff unless there's no bugs, there's no static analysis complaints. So that's an example of how high is the quality bar. So what I'm saying is that we're kind of building a conflict. Here's your task, you're going to get the money when it's merged, but you're not going to get merged if the quality is not high enough. And we do it for every single task. So for every single increment, for every single developer who is trying to change the code and commit the new stuff into our code base, into master, we always check the quality. We always check the quality. So when the project is 1 year old, we merged already 1,000 pull requests. And for all these 1,000 pull requests, for 1,000 steps, micro increments, we check the quality again, again, and again, and again. So in the end, the quality is really high. Again, you can check our GitHub projects in Java. You will see how high is the quality of our code.
Okay, great. There was a comment. Maybe you have something to say about it. Even prisoners are allowed one call.
Well, yeah, for the call. Yeah, I've heard that complaint a lot. So people saying like, hey, we're people, we love to call each other, we love to say good morning sometimes. What kind of work is that when there's like, yeah, people don't talk to each other? I also thought so. I had that fear years ago when I introduced that. I was like, hey, programmers not going to like it because they kind of used to talk to each other. They love all these Slack chats and hashtags and everything. But when we're talking about A players, when we're talking about senior developers, they really don't like that. They like to stay focused on their stuff, which is really interesting for them. They have other places where they can talk to somebody, they can have beer, they can smile, they can joke. The work and the project is the place where people are interested in professional growth, not interpersonal communications, in my experience. Because let's face the reality, the project is just a temporary group of people who have nothing in common, basically, in most cases. They're from different countries, they're from different cultures, they're different ages, they're just different people. They come together because they are Java experts, for example. And this is what they have in common. That's it. They're not friends. They've never been to school together. They don't live together. They don't have, their families are not friends. So they want to focus on stuff which they have in common. And when traditional projects, trying to make a team of them, trying to use these team building things, and trying to, say like, hey, we're one family. They're not one family. They don't have anything in common. Like, I'm 40, he's 16. What kind of family is this? And this is really annoying for A players. This is really annoying for senior developers to be in the team like that. When people are trying to put them together and say, it's one family, one team, we're all together, they just leave me alone, let me code, let me write the code, let me focus on that. We are doing exactly that. We're just saying remove that interpersonal stuff and focus on the technical problems. And people really appreciate it. A players. C players, yeah, they complain. They complain, they say like, hey, where's your Slack chat? How can I call you? I can explain you, let me call you. And I explain everything. We're just saying, no, here's the ticket, submit the ticket. You don't like the code, you don't like the documentation, submit the ticket. And he's like, it's not really how I'm used to do that, let me call, it's easier for me. It's a clear indication that he's a C player, he or she.
This is awesome, man. So let's move on. If people are only paid for results, how do you handle periods where people have less productivity? They have personal issues, for example, but they are temporary.
It's their own problems. I mean, yeah, but we're adults. I mean, it's business. So we pay people. I mean, our rates are high. That's first. So we pay people. We work remotely, and they're people mostly from not really expensive countries, and we pay like $40 an hour, $45 an hour. It's pretty high rate. So we allow them to make money while they are productive, while they have time. So they are, they should be smart enough, they should be grown up people to manage their own finance, to manage their own money. So save something for the time for your vacation or whatever. So we're not trying to, we're trying to respect our people, with our programmers. We're trying to treat them as equal. They're not kids, they're not children, so they don't need to be patronized like in traditional teams. Like, yeah, we're going to cover your vacation, just sit in the office. Again, it doesn't motivate A players. It motivates C players who knows like, hey, I'm productive now because it's luck. Maybe tomorrow I will stop being productive because who knows what's going to happen. They're afraid of that. And that's why they want to be patronized, protected. They want somebody to take care of them. We just let them take care of themselves. So we treat them equally. This is the project, we have money here. You produce something, you give the results, we transfer the money from here to here. And then we're, just go our own ways. So we don't have any vacations, paid vacations, anything.
Who is responsible for the final production result?
Well, for the final production's result is the architect. So technically, we have an architect, like I said, in any project, and that person is responsible for final production results. And responsible, we don't like the word responsible because responsibility means means that you're going to lose something if something happens. In our case, it doesn't happen. So in our case, if the project doesn't work in the end, then that's it. So there is no financial responsibility of that person. We're not going to say like, hey, now you're going to pay us something because you were the architect for a month and you didn't produce anything. So the word responsible in this case, we don't like to use, even with the customers. So when customers come to us and say like, hey, are you going to be responsible? Is it going to work? We say no. We can't guarantee that the software will work. All we can guarantee that the way we manage the development is effective. I'm always giving this example with the taxi driver. You go into the taxi and you ask, can you guarantee that you will take me to the airport? If the taxi driver is professional enough, he will say like, no, I can't guarantee you that because anything may happen. The car may break, there's going to be a roadblock, whatever, anything can happen. All I can guarantee is that I have a GPS, I have a map, I have a driving license, I have the gas in my car, let's go. Let's go and see what happens. So we are together in this journey, The same should happen in software development. Any attempt to put responsibility on the team, like say, hey guys, whatever happens, you have to make it work, is just against the idea of software development. It's wrong. You shouldn't, if you as a customer, you shouldn't do it like that. You should check how your team works, how effective are the mechanisms and methods they use to organize their work, and then see what happens. And also, it's also related to the estimate. So sometimes people say like, can you estimate the project? How much will it cost? We can estimate, but we never put that in the contract. We can give you some number and say like, we estimate it's going to cost $100,000. Yes, that's an estimate, but it may be $1 million, easy. So we're just going to see what happens. We will drive. We're in the taxi. We will drive. But if on that way, straight there, if there will be some, detours and some roadblocks, then we will make detours, and it will cost you more and more and more. The only thing we can guarantee is that we're not going to cheat. We're not going to, make extra detours. That's what you can blame us for. But don't blame us for, for the road being longer than you were expecting. That's the philosophy. I mean, not every customer will like that, but.
Okay, let's move on. How do you know that your developers didn't form up hidden secret chat groups? How do you know that your developers does not form up a secret chat groups?
Well, yeah, we thought about that. And, when they start working, sometimes they try. Sometimes they try. It's a real story. I had a story with the customer. So the customer came to us, and I explained the idea, like how we work, and he said, like, I love it, let's do it your way. And then we started to work. And then in about a month, I realized that I don't have enough, tickets. So he's coming to me and giving me some information which I can't find in tickets. So he's saying like, hey, we're using that technology, it's really great. And I'm like, yeah, but who made that decision? And he's like, yeah, that developer that made the decision. And I'm like, where's the ticket? And he's like, forget it, no problem, he already made it. And then I realized that he created the chat, the customer, and invited developers there. And they started to talk there. And I'm like, and me and my managers were like watching in the tickets, and the amount of tickets go down, so the conversation stopped there, but the code is being written. So they write code, they make decisions, but we don't see what's going on. And then I talked to the customer and said like, do you have some, do they talk to them? And he's like, yeah, what's wrong with that? And I'm like, dude, I told you, that's completely against our, our principles, our philosophy. And he's like, all right, I promise you, no more talking. And then again the same. So he just opened the box and he ruined the whole thing. So in the end, the project failed. In the end, it was nowhere because we completely lost control of the situation. You know, you understand why? Because these people started to talk, they started to make decisions, and then we completely lost control. That's it. So the project failed and quite. And I told him, like this customer, I told him, like, look, I can't be responsible anymore for anything because you're just doing things which are completely wrong. You shouldn't do that. You shouldn't allow them to have that conversation. So it happened. Answering the question, yes.
So one more question. What stops me from generating the bugs I will fix for your money?
What happened?
What stops me from generating the bugs that will get fixed for your money? So basically...
okay, yeah, that's a good question. So what stops the developer from generating, well, writing the code and introducing some bugs, which will be fixed later, and then the developer will make more money, right? That's the question.
Yeah.
Well, first of all, we assign bugs to fix, not to the same people who introduced them. So we randomly assign tickets. So let's say you're the developer. So you create a piece of code, and in that piece of code there are some bugs, intentionally made. Okay, you made them intentionally. But then these bugs will be fixed by that person, and that person, randomly. So there's no real reason for the developer to introduce bugs. Like, I haven't seen that never. So, say again? Well, unless they have a secret chat, but we assign tickets, so they don't make this decision. We always give them tickets. We say like, hey, Jeff, this is your ticket. You can't choose it. I mean, you can say, no, give me that one. It's always randomly, always to random people. That's how we actually solve the problem with no experts at all. So because every time we give bugs and troubles to different people, so they always have to understand the new piece of code. So they always something in the code base, something new arrives to the person, and it helps. So I haven't seen that.
Okay, great. Another question. So how do you decide how much do you pay for a particular task?
Well, like I said, we always give the same budget, let's say 1 hour, and 1 hour means multiplied by the hourly rate of the developer. So we have like a group of developers, let's say 20 people in the project, and that person is $50 an hour, that person is $30 an hour. So, and then we have a bug for 1 hour. So we randomly select the person and give it to that person. Okay, it's going to cost $50. Yeah, like just explained before. So we just always say 1 hour. We don't know. We don't estimate. We don't care. So we just say 1 hour. Well, in our case, it's half an hour. We tried 1 hour, but now we use 30 minutes. So it's always half an hour. And we allow developer to cheat and return back the code, return back the fix, not completely fixed. So sometimes we have bugs which takes, I don't know, 5, 7, 10 steps. So let's say there's a bug, I assign it to you, you fix it, not completely. You just say, hey, for example, I introduced the unit test, which proves that this is not the problem, but I don't know what the problem is. So I introduce new unit test, and I put the new marker saying like, hey, please investigate further, because it looks like here's the new unit test, but it doesn't prove that the bug is there. I return that code back. The new developer picks up the marker and tries again. Again, the developer can't do anything. Again, the new code comes into master branch. The new developer is assigned. The new developer is assigned. So we can jump back and forth on these iterations, sometimes for 10 times. And eventually that will be fixed. So the total cost of the bug will be 10 multiplied by 30 minutes. So it's going to be 300 minutes, the total budget. But it's going to be 10 increments. 10 increments with 10 people, which is a way more manageable situation comparing to one person, 300 hours or 300 minutes. Hey, here's your task, work for 300 minutes, which means what, 5 hours. Maybe you will fix it. In our case, it's going to be 10 people touching that problem, 10 people. Eventually, the person number 10 will fix it. Which one is manageable, more manageable? Obviously, our approach. So we don't estimate, we just always say 30 minutes, half an hour, whatever you do, half an hour, do something, do something, do something. And then we iterate.
Okay, great. What about ops? What about operations and infrastructure? How do you pay for that?
Well, for DevOps, it's kind of something we haven't touched like seriously. So I'm not sure how it's going to work for DevOps, for the current situation with DevOps, where people actually, configure servers and install something on servers. So my answer is I don't know. We'll try. We haven't touched that area yet. Maybe with the immutable servers, which I think is going to be the future, when we'll have immutable servers and then the entire infrastructure will be kept in the repository as a code, and everything will happen in the code, and then the infrastructure will be automatically deployed to production, like in one click, then probably DevOps will be equal to developer, and then the problem will be solved. But right now, it's more like people with the SSH consoles, so it's difficult to do anything like that.
If the server is down, does PagerDuty also just open a ticket?
Well, in most cases, if the server is down, we also open the ticket. We also open the ticket and say, hey, somebody fix that. And then sometimes, it's a good question, sometimes we need that ticket to be fixed now instead of in 5 hours. In that case, we increase the budget. We just say it's not 30 minutes, it's 2 hours. Even though we understand it's a work for 5 minutes or 15 minutes, we just multiply, we boost the budget. We say like multiply. And it means like the developer will pick it up immediately and will try to do everything to close it because the budget is way higher. So we actually motivate by money, which is a really good thing. So most people say that money is not a motivator. We completely disagree with that. Money is the greatest motivator. Is the greatest motivator ever invented in human history. We don't need anything else. We don't need this, tennis tables in the office. We don't need these coffee machines. We need money. Just give money to people in a clear way so that developers will understand why the money coming there, how to increase the amount of money. I don't need the soft skills. I don't need to please my manager. I just need to close more tickets. This is, I think, a way more productive, approach to motivating people. There's the question here, maybe, yeah. Taxes. Well, we pay taxes, programmers pay taxes. So programmers, when they send money to programmers, they pay their own taxes, of course. Yeah,
okay.
Obviously, yeah.
How much do you pay managers and how?
Well, for managers, we pay in the same, well, we also pay by task. And so the more tasks manager is managing, is assigning, closing, the more money the manager gets. So we're always trying to attach everybody in the project for results. So the more the project produces, the more we deliver to the customer, more code, the more everybody gets. And the customers appreciate that, and we build them like that. So in the end of the week and of the months, we just show the customer the total amount of tasks we closed, bugs we solved, and this is the amount of money the customer pays us. Yeah.
Okay.
We have 2 more minutes.
Who is breaking up work in chunks? What if the chunk is too big?
Well, I just explained that. I explained that we just give the full chunk to developer, and then we allow developer to cheat. So that's how we break it.
Do you even have permanent employees in the company except yourself?
Well, I'm in general against permanent employment. I think it's a modern form of slavery. So this long-term employment is, well, it's really good for lazy developers. It's perfect. Because like I said, no matter what you do, you get the money. But it's not really good for people who are self-motivated, who are interested to grow, who wants to get pleasure from the work. So this full-time employment, long-term employment is really not productive. It's everywhere right now. All companies pay that, and it's really difficult to fight against that. But I think the future is different. I think in the future we will get more money per hour, but we'll get paid for results. I think that's the future of professional development, not what we have right now. What we have right now is, like I'm saying, it's modern slavery of the 21st century. It's gonna go. Okay,
and the last question from me, actually, to the audience.
Yeah.
How many people agree with this approach?
You see? 50%.
That's a lot. So thank you, Yegor. That was awesome. Thank you.
Thank you very much.